Game theory is a branch of mathematics and economics that studies strategic interactions among rational decision-makers. It provides a framework for analyzing the outcomes of situations where individuals or entities, referred to as players, make decisions with the understanding that their actions will affect the outcomes for all participants. Game theory is widely used in various fields, including economics, political science, biology, and computer science. Key concepts and principles of game theory include: players. Game theory involves multiple decision-makers, known as players, who interact in a given situation. Players can be individuals, companies, governments, or any entities making strategic choices. Strategies. Each player in a game has a set of possible actions or strategies that they can choose. A strategy is a complete plan of action that a player adopts to achieve their objectives in the game. Payoffs. The consequences or outcomes of a game are represented by payoffs, which quantify the preferences of each player for different combinations of strategies chosen by all players. Payoffs can be in the form of utility, monetary gains, or any other relevant measure. Games. Games in game theory are mathematical models that represent strategic interactions. Games are defined by the players, their strategies, the rules of the game, and the possible outcomes, payoffs, associated with different combinations of strategies. Types of games. There are various types of games in game theory, including cooperative games. Players can form coalitions and make binding agreements. Non-cooperative games. Players make decisions independently without binding agreements. Zero-sum games. Total payoff is constant. What one player gains, another loses. Non-zero-sum games. Total payoff can vary. Outcomes are not strictly competitive. Nash equilibrium. A central concept in game theory is Nash equilibrium, named after mathematician John Nash. In a Nash equilibrium, no player has an incentive to unilaterally change their strategy given the strategies chosen by the other players. It represents a stable state where each player's strategy is optimal given the strategies of others. Dominant strategy. A dominant strategy is a strategy that provides the best outcome for a player regardless of the strategies chosen by other players. If a player has a dominant strategy, it is often a key consideration in analyzing the game. Prisoner's dilemma. The prisoner's dilemma is a classic example in game theory where rational individuals acting in their self-interest may not lead to the best collective outcome. It illustrates the tension between individual and collective rationality. Iterated games. In some situations, games are played repeatedly over time, iterated games. The concept of tit for tat, where players respond to each other's previous actions, becomes important in iterated games. Applications. Game theory is applied in various fields, including economics, pricing, competition, political science, voting strategies, international relations, biology, evolutionary game theory, and computer science, algorithm design, network protocols. Game theory provides a powerful tool for analyzing strategic interactions, predicting outcomes, and understanding decision-making in situations where the interests of multiple parties are at play. It has had a significant impact on various disciplines, contributing valuable insights into strategic reasoning and decision-making processes.